Hi, I'm James, and for today's discussion, I'll be one of your teachers. I'll be talking about linear inequality. So without further ado, let's get started! Once again, our topic for today is about linear inequalities, not always equal but always related. This is our learning objectives for today. First, define inequality. Second, find the solution set of linear inequalities in one variable. Lastly, solve linear inequalities involving absolute value. First, let's define inequality. An inequality compares two values that are not equal. It uses symbols like less than, greater than, less than or equal to, or greater than or equal to. Why it's important? We use inequalities to compare quantities, make decisions, solve real-life problems. In graphing linear inequality, we use hollow and solid circles to show if a number is part of the solution or not. Hollow circle, the normal one or the unshaded circle, while solid circle, the shaded or filled-in circle. For x less than to 2 means all numbers less than 2 are included, but 2 itself is not. So, we draw a hollow circle at 2, our endpoint, and shade to the left. In writing, in set notation, we use parentheses to show that 2 is not included. For x less than or equal to 2, all numbers less than or equal to 2 are included. This time, we draw a solid circle at the endpoint, which is 2, and shade to the left again. In writing, in set notation, we use a bracket to show that 2 is included. Next, for x is greater than 2, we include all numbers greater than 2 but not 2 itself. We use a hollow circle at the endpoint, 2, and shade to the right. Again, in set notation, we use parentheses since 2 is not included. Lastly, for x greater than or equal to 2, it means all numbers greater than 2 or equal to 2 are part of the solution. We use a solid circle at the endpoint 2 and shade to the right. In set notation, we use bracket because 2 is included. Always remember, hollow circle and parentheses means not included, while solid circle and brackets means included. And lastly, if the inequality is only less than or greater than, the endpoint is not included. But if it's less than or equal to or greater than or equal to, the endpoint is included. I hope you understand. Thank you.
Good day, class. I'm Fairy Queen Bitanggapan, and today I'll be discussing one of the important parts of our topic, solving linear inequalities in one variable. Let's start with the first one, the transitive property. For any real numbers, a, b, and c, inequalities follow several properties. If a is greater than b, then b is greater than c, then a is greater than c. Another, if a is less than b and b is less than c, then a is less than c. And you may also apply the transposition method. Mao ning diretso na dili na nimo siya kailangan gamiton og additive inverse. I'm showing this para magkaroon kayo ng option kung unsa ang tan-aw ninyo nga mas dali nga way para pag-solve ng linear inequality. Transposition, when we say transpose, always remember to change its sign. So let's have an example. X plus 5 greater than 10. So, kani si plus 5, dapat kauban dyan niya si 10. So, ato ni siyang i-transpose. X greater than 10 minus 5. So, i-copy na nato ni sila. And also, do not forget to change the sign. So, gi-minus nato si 5 kay plus 5 man siya. And the answer is x greater than 5. Kay 10 minus 5 equals 5. And then, pag i-graph na natin siya, plot po natin yung endpoint. So, it is shaded or not? Not, kaya wala man siya equal sign. 5 is not part of the solution. Dapat dili siya shaded. Hollow lang dapat siya. Now, where's the direction of graph? So, kay since greater than man siya, so pa right. Or, in another way, pwede ka mo gamit ani. So, nag-start tayo sa 5. And then, papunta tayo sa positive infinity. Take note, 5 is not the part of the solution, kaya mo gamit ta og parentheses. Okay, how do we write the set notation? Set of all x such that x greater than 5. In the second example, we have x negative 2 less than or equal to 5. So again, wala siya dito sa pwesto niya na dapat kakasama niya yung kapareho niyang constant or i-transpose natin siya sa right side. And do not forget to change the sign. And magiging x less than or equal to 5. From negative 2, magiging plus 2. And the answer is x less than or equal to 7 because 5 plus 2 equals 7. And then, pag i-graph na natin siya, plot first your endpoint. Ito po siya. It is shaded or not? Solid or hollow? Solid. Kasi po may equal sign. So, part of the solution yan. So, since pala po siya, tapos nag-end siya sa 7, so ibig sabihin ito ang ilalagay natin sa kanan. Now, so negative infinity kasi papunta ito sa negative. Negative infinity hanggang positive 7, which is 7 part of your solution. Kaya ang ginamit ko dito ay bracket kasi shaded siya. Or pwede rin pong sa set notation. X such that x less than or equal to 7. And that's all.
Good day, everyone. I am your teacher, Jinky, for today. And today, I will be discussing to you about the linear inequalities. But before that, you need to be listen, watch, and learn. Addition property of inequalities. If A less than B, then A plus C less than B plus C. And if A greater than B, then A plus C greater than B plus C. To isolate the variable, we add C from both sides. Even the symbol are different, the process will be the same. Solving linear inequality. In applying the addition property of inequality, we have here an equation which is x plus 3 less than 2. Then, you just copy the x plus 3 less than 2. Then, add the additive inverse to eliminate the constant, which is the negative 3. Now, let's cancel out the constant. Subtract 3 from both sides, then simplify it. Now, we have our answer, which is x less than negative 1. Now, let's do the graphing. Let's plot first the endpoint, which is the negative 1. If you are wondering why is the dot is not shaded, it means the negative 1 is not included in the solution. Since the symbol is less than, the line will be running going to the left side. We can also write it as from negative infinity and to the negative 1. But take note, negative 1 is using the parenthesis. It means negative 1 is not part of the solution. And now we may write the set notation as the set of all x is less than negative 1. Now let's have the number 2 is x minus 7 greater than or equal to negative 4. Now we will still do the same process. Copy the inequality. Then add the additive inverse in both sides. Since our constant here is negative 7, so that we add the positive 7. And now let's do the cancellation, then subtract the negative 4 plus 7. So we have now x is greater than or equal to positive 3. Now let's do the graphing. And now let's plot the positive 3. Since the positive 3 is included to our solution, the dot will be shaded. And now our symbol here is greater than. Our line will be running to the right side. In another way to write the notation, we can also write 3 and 2 the positive infinity. As you can see, 3 is using a bracket. It's because 3 is a part of our solution. That's why our dot here is shaded. Now, when we are writing the set notation, we write it as the set of all x such that x is greater than or equal to positive 3. It depends to you on how you write the set notation.
Good day, class. I'm your teacher, Kim, and today we're going to learn another important part of algebra, solving linear inequalities using the multiplication property of inequalities. So get ready and let's begin. Lesson today will focus on how multiplying or dividing both sides of an inequality by a number affects its direction. By the end of our discussion, you'll be able to solve linear inequalities and understand when and why the inequality sign needs to be reversed. So get ready and let's begin. Here our first example, and let's solve this inequality. X over 3 less than negative 2. Here x is divided by 3. To isolate x, we do the opposite. We multiply both sides by 3. To simplify both sides, on the left we have 3 and cancels with the denominator 3. And we have the remain x less than negative 2 times 3 is negative 6. So the solution is x less than negative 6, which means any number less than negative 6 makes the inequality true. If we graph it on a number line, we put an open circle at negative 6 because the inequality is less than and negative 6 is not included in the solution. And shade the line to the left showing all numbers less than negative 6, or start the negative infinity up to negative 6. I use parentheses because negative 6 is not part of the solution. So our set notation, the set of all x such that x is less than negative 6. So let's proceed to the next example. We have negative 2/3 x less than or equal to negative 6. To isolate x, to do that we need to remove the fraction negative 2/3. We can do this by multiplying both sides by the reciprocal of negative 2/3, which is negative 3/2. On the left, cancel out, and we have the remain x. But remember, since we are multiplying by a negative number, we must reverse the inequality sign. So we have x greater than or equal to negative 6 times negative 3/2. Now let's simplify it. X greater than negative 6 times negative 3 is 18 divided by 2 is positive 9. So the solution is x greater than or equal to 9. If we graph it on a number line, we put a closed circle at 9 because it's greater than or equal to, and shade to the right to show all numbers greater than or equal to 9. Or the set start from positive 9. I use bracket kay part siya sa solution up to positive infinity. So our set notation of all x such that x is greater than or equal to 9.
Good day, class. I am teacher Jenny. Today we will proceed on how to solve linear inequalities involving absolute value. Before we dive into the specific rules, let's quickly remember the difference between linear equations and linear inequalities. When it comes to linear equation, when we solve for x, there is a definite value for x. There is a single value for x. But when it comes to linear inequalities, there are so many or infinitely many number of possible solutions or possible value for x. Now, what absolute value means? The absolute value of a number is its distance from 0 on the number line. Because it is a distance, the result is always positive. When we combine absolute value with inequalities, we're asking a question about a range of distances. The 4 rules na makita nyo dyan, it give us a straightforward way to solve these problems by converting them into standard inequalities we're already familiar with. We have here the rules or properties for solving absolute value inequalities. The first rule, the absolute value of x is less than a if and only if negative a is less than x, which is less than a. What it means, if the absolute value of x is less than a certain number, then x must be between the negative of that number and the positive of that number. In simple terms, x is between negative a and a. The second rule, the absolute value of x is less than or equal to a if and only if negative a is less than or equal to x, which is less than or equal to a. Buot ipasabot, if the absolute value of x is less than or equal to a certain number, then x must be between the negative of that number and the positive of that number, including the endpoints. In simple terms, x is between negative a and a, including negative a and a. The third rule, the absolute value of x is greater than a if and only if x is less than negative a or x is greater than a. If the absolute value of x is greater than a certain number, then x must be less than the negative of that number or greater than positive of that number. In simple terms, x is either less than negative a or greater than a. We have here the fourth rule. The absolute value of x is greater than or equal to a if and only if x is less than or equal to negative a or x is greater than or equal to a. Meaning to say, if the absolute value of x is greater than or equal to a certain number, then x must be less than or equal to the negative of that number or greater than or equal to the positive of that number. In simple terms, x is either less than or equal to negative a or greater than or equal to a. We have here an example. Example 1. Absolute value of 2x minus 1 is less than 5. Meaning to say, we want to find all the values of x that make the distance between 2x minus 1 and 0 less than 5. Because the absolute value is less than a number, we use this rule. Absolute value of x is less than a means negative a is less than x is less than a. Now, rewrite as a single inequality. This rule tells us to rewrite our problem as a single, three-part inequality. The negative 5 is less than 2x minus 1 is less than 5. Then solve. Our goal to solve is to get x by itself in the middle. Then add 1 to all parts. Negative 5 plus 1 is less than 2x minus 1 plus 1 is less than 5 plus 1. Negative 4 is less than 2x is less than 6. Then divide all parts by 2. Negative 4 divided by 2 is less than 2x divided by 2 is less than 6 divided by 2. Therefore, we have negative 2 is less than x is less than 3. Meaning to say, any x value greater than negative 2 and less than 3 works. Again, we have inequality notation for example 1. We have negative 2 is less than x is less than 3. It means x is greater than negative 2 and less than 3. But we can also represent our answer using set builder notation, interval notation, and graphical method. For set builder notation, the set of all x such that x is greater than negative 2 and less than 3. No, nasa ubos, makita ninyo. This defines all real numbers x that are strictly between negative 2 and 3, excluding the endpoints negative 2 and 3 themselves. For interval notation, we have open parenthesis, negative 2, comma, the 3, close parenthesis. That is our interval notation. It means all numbers between negative 2 and 3, excluding negative 2 and 3. The parentheses mean we don't include the endpoints. Third one is graphical method. How to draw it? Draw a number line, put open circles at negative 2 and 3 because we don't include these numbers. Then draw a line connecting the two circles. It means the open circles shows that negative 2 and 3 are not part of the solution or not included of the possible values of x. Proceed tayo sa example 2. We have an example, absolute value of 4x minus 8 is less than or equal to 12. So meaning to say we want to find all the values of x that make the distance between 4x minus 8 and 0 less than or equal to 12. Because the absolute value is less than or equal to a number, we use this rule, the rule number 2. The absolute value of x is less than or equal to a means negative a is less than or equal to x is less than or equal to a. Then, rewrite as a single inequality. Again, this rule tells us to rewrite our problem as a single, the three-part inequality. We have here negative 12 is less than or equal to 4, x minus 8 is less than or equal to 12. And then solve. Here our goal is to get x by itself in the middle. Then after that, add 8 to all parts. We have negative 12 plus 8 is less than or equal to 4. X minus 8 plus 8 is less than or equal to 12 plus 8. We have negative 4 is less than or equal to 4x is less than or equal to 20. Then divide all parts by 4. We have here negative 4 divided by 4 is less than or equal to 4x divided by 4 is less than or equal to 20 divided by 4. Therefore, we have negative 1 is less than or equal to x is less than or equal to 5. Meaning to say, any x value greater than or equal to negative 1 and less than or equal to 5 works. Again, we have different forms to represent our answer. The set builder notation or the set notation. The second is the interval notation and the graphical method or graphical form. Okay, for set builder notation, the set of all x such that x is greater than or equal to negative 1 and less than or equal to 5. No? Yun yung set builder notation natin. And the second one, for interval notation, we have left bracket negative 1, comma, 5 right bracket. So meaning to say, all numbers between negative 1 and 5, including negative 1 and 5, the square brackets mean we do include the endpoints. Lastly, we have graphical form or graphical method. How to do it? Draw a number line, put solid circles at negative 1 and 5 because we do include these numbers. Draw a line connecting the two circles. Meaning to say the closed circles or the solid circles show that negative 1 and 5 are part of the solution or the possible value of x.
Hello everyone, I am Teacher Jana for today's video. Earlier, Teacher Jenny explained and demonstrated how to solve linear inequalities using rules number 1 and 2. Now, I will explain and demonstrate how to solve absolute value inequalities using rules number 3 and 4. Okay, let's get started. This is rule 3, which states that the absolute value of x is greater than a if and only if x is less than negative a or x is greater than a. So what's the purpose of this rule? Ang Rule 3 ay ginagamit para hanapin ang lahat ng mga numero na higit pa sa isang distansya mula sa 0. Here's a given problem. The absolute value of 5x minus 10 is greater than 15. Rule 3 tells us to split our problem into two cases. Case 1 on the left, case 2 on the right. Going back to the given problem, we have 5x minus 10 is our x, while 15 is our a. Substituting, we get 5x minus 10 less than negative 15 as case 1, while 5x minus 10 greater than 15 as case 2. Now, let's start solving the case 1 on the left side. 5x minus 10 less than negative 15. Our goal is to get x by itself. In simpler terms, we need to isolate x na si x na lang mabilin in one side of the inequality. To solve x, our first step is to eliminate the negative 10 by adding positive 10 to both sides. 5x minus 10 plus 10 is less than negative 15 plus 10. Therefore, 5x is less than negative 5. Now, we will proceed in dividing both sides by 5. This gives us x is less than negative 5. This means any x value less than negative 5 satisfies this condition. But remember, Rule 3 gave us two cases. We've only solved the first case. Now we need to tackle the second case. Solving case 2, which is 5x minus 10 greater than 15, just like before, our goal is to isolate x. To isolate x, let's start with adding 10 to both sides. 5x minus 10 plus 10 greater than 15 plus 10. This gives us 5x is greater than 25. After that, we divide 5 to both sides. 5x divided by 5 greater than 25 divided by 5. Now we divide by 5 to get the x completely by itself. This gives us x is greater than 5, which means any value greater than 5 satisfies this condition. So what's the final answer? Remember, Rule 3 gave us two possible solutions: x less than negative 1 or x greater than 5. This means our complete solution include all numbers less than negative 1 and all numbers greater than 5. We will be using three different ways on writing the answer. Using number line representation to visualize what we just found. As you notice, the open circle is put at negative 1 because x is less than, not less than or equal to. An open circle means negative 1 itself is not included in the solution. The arrow is going to the left from negative 1 because x is less than negative 1, it can be anything smaller. While on the other hand, open circle is put at 5 because x is greater than, not greater than or equal to 5. And the arrow is going to the left from 5 because x is greater than 5, it can be anything bigger. This number line gives you a picture of all the possible x values that work. Another way on writing the solution in interval notation. Open interval negative infinity to 1. This means all numbers from negative infinity up to negative 1, not including negative 1. The parenthesis means not including. Open interval 5 to positive infinity. This means all numbers from 5 up to infinity, not including 5. Again, the parenthesis means not including. The use symbol. This symbol means union. It means we're combining these two sets of numbers. Set notation, also another shorthand way to write the same thing. The set of all x values such that x is less than negative 1 or x is greater than 5. We are done with Rule 3. Let's continue with Rule 4. This is what Rule 4 looks like. Noticing it is very similar to Rule 3, right? Almost everything is the same except for the inequality symbol. Rule 3 uses greater than, while Rule 4 uses greater than or equal to in the inequality. If we apply Rule 4 to the same given problem, 5x minus 10 greater than or equal to 15, this is how it looks. It looks very similar, only the inequality symbol changed. The result in solving case 1 will be x less than or equal to negative 1, while case 2 result will now be x greater than or equal to 5. Just like I said, the inequality symbols are the only thing that changes. However, when we combine the solutions and write them in three different ways, just like what happened in Rule 3, the answer will be different. First, using the number line representation, earlier there were open circles, but now they are closed circles. A closed circle is put at negative 1 because x is less than or equal to negative 1. A closed circle means negative 1 is included in the solution. Also, a closed circle is put at 5 because x is greater than or equal to 5. A closed circle means 5 is included in the solution. This is now how the answer looks in interval notation. Pay attention to the square brackets, which indicate that the endpoint negative 1 and 5 are included in the solution. Writing the answer in set notation, the set of all x values such that x is less than or equal to negative 1 or x is greater than or equal to 5. The less than or equal to symbol and the greater than or equal to symbol show that negative 1 and 5 are part of the solution. That's all, thank you.